The Mariana Trench, a scar on the Earth's crust, plunges deeper than any other point on the planet. This underwater chasm, located in the western Pacific Ocean, reaches a staggering depth of about 36,000 feet, or nearly 7 miles. It's a place so remote and so deep that only a handful of manned missions have ever dared to explore its dark, mysterious depths. It's a place of immense pressure, perpetual darkness, and strange bioluminescent life. The creatures that inhabit this abyss have adapted to survive in conditions that would be utterly inhospitable to most life forms on Earth. The pressure here is over 1,000 times greater than at sea level, and the temperature hovers just above freezing. Now imagine dropping humanity's most destructive creation into this abyss, the Tsar Bomba. This colossal hydrogen bomb, developed by the Soviet Union during the height of the Cold War, was designed to demonstrate the sheer power of nuclear weapons. Its detonation would unleash an unimaginable amount of energy. The Tsar Bomba, a Soviet-era hydrogen bomb, stands as a chilling monument to Cold War paranoia. It was tested on October 30th, 1961, and remains the most powerful nuclear weapon ever detonated. The bomb was so massive that it had to be dropped from a specially modified aircraft, and even then, the plane barely escaped the blast radius. This behemoth of a weapon with a yield of 50 megatons of TNT dwarfs any explosive ever detonated. To put that into perspective, the bomb was over 3,000 times more powerful than the bombs dropped on Hiroshima and Nagasaki combined. The explosion produced a mushroom cloud that reached into the stratosphere and was visible from over 600 miles away. What would happen if we unleashed this monster in the Mariana Trench? The idea of detonating such a powerful bomb in the deepest part of the ocean is both terrifying and fascinating. Would the immense pressure of the trench amplify the explosion, or would it contain it? Would it crack the Earth open? The Mariana Trench lies at the boundary of two tectonic plates, and the energy released by the bomb could potentially trigger seismic activity. Could it cause earthquakes or even volcanic eruptions, unleash monstrous tsunamis, wiping out coastlines? The force of the explosion could displace a massive amount of water, creating waves that travel across the ocean at incredible speeds. These tsunamis could devastate coastal communities thousands of miles away. The answer, surprisingly, is less apocalyptic than one might imagine. While the explosion would be catastrophic in the immediate vicinity, the vastness of the ocean and the depth of the trench would likely absorb much of the energy. The pressure and water would act as a buffer, preventing the worst-case scenarios from unfolding. The Earth, it seems, is more resilient than we often give it credit for. To grasp the potential chaos, we must first understand the sheer power of the Tsar Bomba. This colossal nuclear device, detonated by the Soviet Union, remains the most powerful man-made explosion in history. Its creation was a testament to the intense arms race of the Cold War era, where superpowers vied for dominance through sheer destructive capability. Tested in 1961, its fireball stretched for 5 miles, illuminating the sky with an intensity that could be seen from hundreds of miles away. The sheer energy released in that moment was equivalent to 50 megatons of TNT, dwarfing the combined power of all the bombs dropped during World War II, and its mushroom cloud soared 40 miles high, visible for hundreds of miles. This towering cloud of destruction was a grim symbol of the potential for annihilation that humanity had unlocked. The mushroom cloud itself was a chilling reminder of the destructive force that lay within our technological advancements. The shockwaves from the blast circled the Earth 3 times. These shockwaves were so powerful that they were detected by seismographs around the globe, showcasing the far-reaching impact of the explosion. The ground trembled, and the air itself seemed to ripple with the force of the detonation. Windows shattered hundreds of miles from the detonation site. The force of the blast was so immense that it caused structural damage far beyond the immediate vicinity, a stark illustration of the bomb's overwhelming power. Buildings were left in ruins, and the landscape was forever altered. The heat from the explosion could have caused third-degree burns 60 miles away. This intense heat was capable of igniting fires and causing severe injuries at a distance that defies comprehension. The thermal radiation emitted was a deadly force in its own right, adding another layer of horror to the event. It was a terrifying display of raw power, a stark reminder of humanity's capacity for destruction. The Tsar Bomba was not just a weapon, it was a statement of technological prowess, of military might, and of the terrifying potential for self-destruction that lies within our grasp. This legacy of destruction serves as a sobering reminder of the responsibilities that come with such power. Detonating the Tsar Bomba underwater would be a different beast altogether. The Tsar Bomba, the most powerful nuclear weapon ever detonated, unleashed a force equivalent to 50 megatons of TNT when tested in the atmosphere. But what if this colossal bomb were detonated in the depths of the ocean? The results would be both fascinating and terrifying. The immense pressure at the bottom of the Mariana Trench, over 1,000 times atmospheric pressure, would contain the explosion to a significant degree. This pressure, combined with the density of the water, would act as a natural barrier, preventing the explosion from expanding as it would in the air. The water would absorb much of the energy, but the effects would still be catastrophic. The bomb would vaporize a massive amount of water, creating a rapidly expanding bubble of steam and superheated gas. This bubble would grow at an incredible rate, pushing against the surrounding water with immense force. The initial vaporization would be so intense that it would create a temporary cavity in the ocean, a void where the water was momentarily displaced. This bubble, reaching miles in diameter, would be highly radioactive. The radioactive particles would mix with the water, creating a toxic brew that would spread through the ocean currents. Marine life in the vicinity would be instantly obliterated, and the long-term environmental impact would be devastating, with radiation poisoning the waters for years to come. The pressure from this expanding bubble would generate a shockwave, racing through the ocean depths. This shockwave would travel at incredible speeds, causing destruction in its path. The force of the wave would be enough to crush submarines, destroy underwater habitats, and even trigger underwater landslides, further compounding the disaster. This shockwave, while powerful, would dissipate as it traveled, losing energy much faster than in air. The water's density would absorb and spread out the energy, reducing the wave's destructive power over distance. However, the initial impact zone would suffer unimaginable damage, and the reverberations would be felt far and wide, a stark reminder of the destructive potential of nuclear weapons. Section 4. The ocean's wrath contained. Reaching the surface, the shock wave would be significantly weakened. While it might create some unusually large waves, it wouldn't be the monstrous tsunamis often depicted in disaster movies. The real danger lies in the radioactive fallout. The explosion would release a plume of radioactive material into the ocean. However, the vastness of the Pacific Ocean would dilute this, making its impact far less severe than an atmospheric detonation. Section 5. Life finds a way, but not here. The immediate impact on marine life in the vicinity of the explosion would be devastating. The heat, pressure, and radiation would obliterate anything within a considerable radius. The long-term effects are harder to predict. While the ocean is vast, the radioactive material could disrupt delicate ecosystems and potentially impact marine life far from the blast zone. Section 6. Earth's unfazed giants. Now for a dose of perspective. As massive as the Tsar Bomba is, its power pales in comparison to the forces constantly at play within our planet. Earthquakes routinely release energy equivalent to hundreds of Tsar Bombas. Volcanic eruptions dwarf even the most powerful nuclear explosions. The movement of tectonic plates, a slow, grinding dance, makes our bomb look like a firecracker. Section 7. A drop in the ocean of time. The detonation of the Tsar Bomba in the Mariana Trench, while a horrifying thought experiment, ultimately wouldn't break the Earth. It wouldn't even leave a lasting scar on a geological scale. The ocean is vast, powerful, and surprisingly resilient. While we should never underestimate the destructive potential of our creations, it's important to remember that nature plays on a scale we can scarcely comprehend. The real takeaway? Let's not find out.